Okay, so for this problem, we have on my side note here 4x to the third plus 4x to the second plus 3 all divided by x to the second minus x. What I see, the highest power of the numerator is 3. Highest power of the denominator is 2. So this case, 3 greater than 2. So make it improper. When you have the improper, we're going to do the long division technique or process the long division method to get the whole number plus or the whole expression plus the proper fraction. Okay, to do the long division process, if you recall, that's great. If not, I'll do a quick review here. So we're gonna start with writing the numerator and put it in the order of the power. We are missing the power 1. I'm going to put as 0 times x to the first power and then plus 3. Okay, and then make a symbol of the long division and then the divisor x squared minus x. Starting with dividing the first term by x squared. X squared goes to 4x to the third. What you're gonna get? You're gonna get 4 times x to the second. Okay, and after that you multiply 4x to the second to no 4x to the first, sorry. So you multiply 4x and x squared to get 4x to the third. You're supposed to get exactly the same term. After you get this, you're going to multiply again with the negative x to get negative 4x to the second. Draw the line. At this step, we're going to eliminate or subtract them from the original expression of the numerator. So you have 4x to the third, 4x to the third, subtract, right? They're all gone. And the next term gonna be 4x squared minus negative 4x squared. So we're gonna get 4 plus 4 or 8x squared. And then bring the next power down, okay? And then what we're gonna do, we're gonna keep going by do the division. How about x squared goes to 8x how many times? And the result is 8 times. So that means 8 multiplied by x squared, we get 8x squared. And then following by multiplying 8 with the negative x, draw the line, put together, and then subtract from the previous row. When you do this, the 8x squared will be gone. And the next 0 minus negative 8x will give us positive 8x, and then plus 3. We bring the next term down. At this step, you have 8x to the first power. The power 1 is lower than the power 2, so this one is called the remainder. Okay, in summary, the expression that we have, the 4x to the third plus 4x to the second plus 3, all divided by x squared minus x. Using the long division, we're going to get the whole expression 4x plus 8 plus the remainder 8x plus 3 divided by the denominator, which is x squared minus x. So now we have the whole expression plus the proper fraction. So the remainder divided by denominator becomes proper because the remainder has less power than the denominator. Back to the main problem. So this one now becomes the integral of 4x plus 8 and then added by the quantity 8x plus 3 divided by x squared minus x with respect to x. Okay. To see this as 1, 2, 3, 3 terms of the integrand. So I'm gonna break it up as the whole thing, leave it alone because we don't have to do anything with the partial fraction plus the integral of 8x plus 3 divided by x squared minus x with respect to x, which for the process of the partial fraction, I'm gonna factor the denominator completely. So I have x multiplied by x minus 1. Okay, this case, it returns this as the linear, and this one is linear, and the power 1, and the m equals 1. M equals 1. What is m? M is the power of that linear factor. That will tell you how many partial fractions you're going to have to break it into. Okay, so for the first two terms, we're going to get 2x squared plus 8x. So set it aside. And then for the partial fraction one, we're going to have to perform the partial fraction. The first one is linear, going to be divided by x here plus divided by x minus 1 with respect to x. And since the linear numerator must be the constant, so I use the number a and number b as before, or you can use a1, a2, up to you. It doesn't matter. So at this step, I'm going to add another slide to make more room and then work on the detail of the partial fraction. Okay, so far we have 2x squared plus 8x plus the integral of a over x plus b over x minus 1 with respect to x. And then work on the, I'm going to put the side note on this side and use different color here. So from original fraction, this is from what we did before, which is 8x plus 3 divided by x times x minus 1, right? So on the prep work on the side here, I'm going to equate 8x plus 3 over x times x minus 1 and the two partial fractions, which is a over x plus b over x minus 1. Combine the fractions on the right hand side using the common denominator. So we have a multiplied by x minus 1 plus b times x, because you're going to have to multiply this, the first one by x minus 1, and the second by x and by x, okay, to have the same denominator. And after that, I can see the left hand side numerator the same or equivalent to the right hand side numerator, which means I equate 8x plus 3 and a times x minus 1 plus bx. Okay, we ignore the denominator because both sides, they have the same denominator. Our goal is to find a and b for this process. Find a and b. Okay, to find a and b, this one is convenient. You have two unknowns, a and b, and then you see the a multiplied by x minus 1 and b multiplied by x. So you can pick any, the convenient number to eliminate x one time and pick another convenient number to eliminate the b another time, like what we did in the last example. So if I pick the value x equals 1, I replace the entire equation by with the x equals 1. So I have 8 plus 3 equals a times 1 minus 1, that is 0, right? So going to be 0 here, plus b times 1. That means my b is 11. I get the answer for b. B is done. B is 11. And next, I choose another convenient number to eliminate the term b. My convenient number for this case is going to be 0. If b is 0, 8 times 0 is 0 plus 3. Left hand side is 3. The right hand side is going to be a times 0 minus 1, which is negative a, plus 0 from 0 times b. No, this is x, sorry. This is x equals 0. So then my a equals negative 3. I get my value a out. Okay, the prep work is done. So my integration now becomes 2x squared plus 8x plus the integral of 3 over x. That's negative 3, sorry. Negative 3 over x plus 11 over x minus 1 with respect to x. And then finish it up by finding the antiderivative of negative 3 over x, which is negative 3 times natural log of absolute value of the x. And the next one is 11 absolute value of x minus 1, and then plus c from using the u sub by letting u be x minus 1 and the du is dx. Okay, so this is our answer, which is the answer of the integral of 4x to the third plus 4x to the second plus 3 all divided by x squared minus x with respect to x.